variance and standard deviation. Variance and standard deviation, first thing I know is what does it measure? It measures how spread out your data is. So if I gave you some data that, I don't know, falls like this, another one that kind of fell like this. See how this one's a lot more clustered? The standard deviation, which by the way the symbol for that is sigma. And then that standard deviation will be kind of small. It'll be like, I don't know, 0.4. For this one where it's all kind of spread out, standard deviation for that's going to be much bigger. It might be like 3.1. So that's what it measures. Standard deviation variance just measures how spread out your data is. So if it's all kind of close together, small standard deviation, it's all far apart, it's a big standard deviation. Now here's the thing. In your formula sheet, you're not going to find any formulas for variance standard deviation because IB doesn't care about that anymore. They do actually care about one thing, and that is you got another relationship between variance and standard deviation. Now you guys probably all seen this in physics, but the main thing to know about, and that is that standard deviation, I'm just going to write like this, is just the square root of variance. That's the main thing IB wants you to know. So sometimes they'll give you the variance, they want you to find the standard deviation, so you just got to square root it. Sometimes they give you standard deviation, they want you to find the variance. So, well, you just got to square it, right? Because if variance is the square root of standard deviation, then standard deviation squared equals the variance. So that's the main thing I know about variance and standard deviation, is that relationship right there. That's what IB cares about. The key thing about this though, how do I remember this? I know that, I remember that it's a square root relationship. How do I keep track which one's which? I just remember this. Variance is bigger. That's how I do it. I just remember that variance is bigger. So if they give me standard deviation, I'm like, okay, that's a smaller one. I got to square it to get to the variance. If they give me the variance, I'm like, okay, that's the bigger one. I got to square root it to get to the smaller one. So that's how I remember it. Let's do a couple quick examples to make sure we got this. Let's go right here. All right, so this is our first example. If the variance is 9, what's the standard deviation? So again, just keep in mind, variance is the bigger one. It's like, okay, it's a bigger one. I got to square root that. 3. So standard deviation is 3. Right, likewise down here, if the standard deviation is 4, what's the variance? Well, again, variance is the bigger one, so I got to get to the bigger one, so I got to square it. And 16 would be my variance. Now, a lot of times, IB is not going to be like that straightforward. They're going to ask you a question where they want the standard deviation, but they give you the variance. You got to keep in mind, like, okay, I got to square root it or square it to get to the thing I want. But that's the main idea. Okay, let's do a quick example of how to relate standard deviation. The number of points scored by Andrew and Brad in the last 8 basketball matches are tabulated below. Find the mean and standard deviation of the number of points scored by each player. Which of the 2 players is more consistent? Remember, that has to do with standard deviation, right? The smaller standard deviation is more consistent. Now, how am I going to find the actual values? Well, we're going to use the calculator. Remember, IB used to have standard deviation and variance formulas in your formula sheet. Not anymore. They took them out because they're only going to expect you to find this stuff. They want you to find it on your calculator on paper too. So we're going to go to our favorite stat edit. We're going to type in data. Remember, if you have values in there, just go to L1, L2 and clear them. So let's type in Brad for Andrew first, I guess. 23, 17, 31, 25, 25, 19, 28, 32. I'm going to go ahead and type in Brad while I'm here. 9, 29, 41, 26, 14, 44, 38, 43. Okay, then we're going to get out. Go to stat, calculate. Now again, some people were tempted to put 2 variable stats. We never ever use it in IB. Never use 2 variable stats. It's always 1 variable stat. So we just gotta go one at a time. So 1 variable stat L1. The other people might be oh, there's a second line, frequency list. No, nothing says frequency. Just gonna do it one at a time. So clear that frequency list. Let's just find out what Brad's stuff is first. So plug it in. So the mean for Brad, or for Andrew. So the mean for Andrew, if I look at my calculator here, it is 25. So the mean, X, a line over it, 25. Now the standard deviation, I'm going to talk about this right now. There's 2 types of standard deviation that the calculator finds you. Mean and population, or sample and population, I should say. So these are both standard deviations, S and that sigma. S stands for sample, this one stands for population sigma. The only one IB uses and cares about is the population one. So always use the sigma one, the one you're used to. So always use that one. So my standard deviation here is going to be 4.97. Now let's do the same thing for Brad. And actually, this while I'm here, the proper symbol for mean, you can see this a lot more. That's the symbol for mean, but also this. Now let's look at Brad's. So I'm gonna do the exact same thing, stat, calculate, one variable stats. Now I'm gonna change this to L2 because I had Brad in L2. So second L2. Again, no frequency list still. Plug it in. Brad's average is 30 and his standard deviation is 12.5. 30.5. 12.5. So you can see from this data, well, Brad has higher average. His standard deviation is he's not consistent at all. He's super all over the place, as you can see by the scores. Andrew's more consistent. So let's look at this quick example real quick. You can do the same thing with frequency. If I give you a frequency, you could do the exact same thing. You go stat, edit. Let me clear my list here. You can type in the data. So number of children, 0, 1, 2, 3, 4, 5, 6, 7. Then over here, frequency. So 14, 18, 13, 5, 3, 2, 2, and then 1. Right, so there's my X and my frequency. If I want to find a standard deviation, I just do the same thing we always do. Stat, edit, one variable stats. Now I have L1 is my normal thing, so second L1. I actually have a frequency this time, so I'll put L2. Hit calculate, and there you go. You have your mean, and you have your standard deviation. Again, we're always going to use the population. And I know they say sample there, I know they do. IB only cares about the population. When it's an IB test, they're only ever going to give you population. So that's how you do it with your calculator. Now let's go over one final example that talks about how mean and standard deviation are affected. So let's look here. Given a set of data that has a mean of 5 and a standard deviation of 2, answer the following. If all the data is increased by 5, what is the new mean and what's the new standard deviation? So let's think about this. Mean is just the average. So if you add 5 to all the numbers, you're just going to add 5 to the average. So let's say my average is this. That's what mean is. If you just add 5 to everything, you're just going to add 5 to your average. So my new mean is going to be 10 plus 5 or 15. Now let's think about standard deviation. Standard deviation talks about how spread apart the data is. Well, if you add 5 to everything, it's still the same spread apart. You just added 5 to everything. So this actually doesn't change when you add something to it. Standard deviation stays the same. So my standard deviation is still going to be 2. So keep that in mind. When you add or subtract a value to a set of data, same value to a set of data, the mean is going to change by that value. You just add or subtract that value. Standard deviation is going to stay the same because remember, standard deviation just measures how far apart stuff is. And if you just add 5 to everything, it's still going to be the same far apart. Now let's contrast that with what happens if you multiply everything by a number? So if all the data is multiplied by 3, what does the new mean? Well, kind of the same idea. Now you multiplied everything by 3. If it averages out, you just multiply your mean by 3. So this would be 3 times 10, which would be 30. Now standard deviation, remember it measures how spread out it is. Now this one's actually different than before, right? Let's say I had 2 and 12, because I mean of that. Let's go 2 and 18. There you go. Right, if you multiply everything by 3, you're going to get 6, and you're going to get 54. That's a lot more spread out than 2 and 18 were. So it actually does affect the standard deviation when you multiply by a number. The way it affects it actually is you multiply by it, just like when you do the mean. So it's going to be 3 times 2, which is 6. So to recap, standard deviation does not get affected by adding or subtracting the same number to a data set. Mean does. But when you multiply, then they both get affected the same way. You just multiply multiply your old values by your new value, by the new value. And there you go. That's it for standard deviation variance.